Well, thanks again for having me. And yeah, I investigated the LLMs and ChatGPT as it came into the market a couple of years back, and I realized, oh, I need to work with that a little. And then I stumbled upon the hallucinations. So this session will be sharing my findings and how I actually use that to my benefit. First of all, um, my name is Marco Wobben, and I'm trying to figure out some screen still. Okay, so here, there you go. And but then again, that's just my name. That's what we call data, and there's a thing called reality, which is the life that I lead. And I've had my company since mid-90s. I've been software developing since, well, maybe since I was 14 years old. Illustrator and raised and educated by various people that showed me how to do my work. And I run my little family with my wife from the USA currently. So let's dig in. There's a lot of talk about data and what that beholds, and I would like to start with a small history lesson. In the old days, we exchanged information by manual means. We communicated orally, and thanks to the printing press and mechanization and industrialization, that information was um, shared in a different way. The printing press, a massive change to humanity, and and it didn't stop there, as we all know it, because nowadays we share information electronically. And this brings along different challenges again. We've seen decades of computer systems development, database development, internet development, and web applications, web services. We have data all over the place. In reality, however, data is usually stored in silos, disconnected from each other, built for a specific context. Um, and if you do not know the context, you don't know what's in the database. And this is where we start becoming counterproductive if we want to build the company as an enterprise or do data management, business management on more than just one single context and one little silo. So what we really see is that if we dig into that, all of that data is fragmented. We can see all the different pieces. If any luck, we have a little bit of metadata around it, but it's still really not connected. So what makes this real connection between data? If we want to operate the organization as a whole and use data as one, we need to focus on the communication that actually created the data, and we need to focus on the communication that connects the data from different contexts and different domains. Now, to make sure, and everybody will understand that, is seeing kids grow up with social media and smartphones, is that communication is all about data, but data is not communication. And there is far more to that. And in the same vein, communication is not just about the words, and everybody who has been in a relationship or is in a relationship will realize that there is far more to it than just the words being exchanged. Everything has a specific context, and it's the same within departments, organizations, and data context. So this is where we find that the approach that we use, called fully communication-oriented information modeling, finds its purpose. It's a way of modeling what is being communicated about data. And we do that in the natural language of the domain experts or the users within the organization. Not in any technical fashion, but just in a natural language. And this is where the overlap starts with the current status of LLMs. and that has my interest specifically. Now, in a simple overview, fully communication oriented information modeling means that we focus on how people working with the data talk to each other about the data. And the information modelers, the information architects, the data modelers try to capture that communication and then generate or build abstract models and software to have automation that actually supports those people that actually do the communication with IT systems. Now, there is a little circle that sketches this. This is what we try to aim to support the communication of the domain experts. And within the method and within the tools, it kind of works like that. We solicit in an interview certain fact statements. And you can see that we have a couple here that says employee 465 performed a checkup for patient 564432 on the checkup day of 2010-10-13. Now, the domain experts can all read that and when they can verify that. In the information modeling part, we dissect that, and in the interview, we try to decipher what the hidden meanings is, what the components are, what the relationships are between various parts in those verbiages. And once we've done that, we can then start automating the stuff. We can graphically visualize those structures, provide the examples, add the semantics, the communication, and from there, we can generate all kinds of artifacts, which shows again the path from interview to capturing the knowledge to driving IT artifacts. For instance, this checkup, we can generate a database table from that. We can generate XML or JSON structures from that, export it in various formats, either in SQL or in a JSON schema draft. Now, the crucial part here is that the information modeling is not about tables and entities, classes, columns, or properties by itself. It's not about all the various technical artifacts such as XML and JSON or API, OWL, RDF, you name it. The information modeling focuses on the relationships themselves because those are the actual building blocks. Now, relationships, you can find this everywhere. And as I've spoken to people in the field, is that everything can be depicted as a graph, but not every graph is depicted as something meaningful. So though the relationships are the essential building blocks, it needs to come within a certain context. It needs to have certain meaning. It needs to have a solid boundary. And if that doesn't work, then yeah, costly results can be the consequences of wrong information models, wrong data models, wrong data usage, not getting the context right. And we all want to prevent that. We want to do meaningful things and we want to do correct things, which requires us to start correctly. Now, this is where the LLM comes in. An LLM, as we all know, is very powerful. It's captivating in a way, but it also comes with a certain risk, and we call that hallucination. Um, Recently, more articles came out that it hallucinates because it never learned to say, I don't know. And this talk is not about how to train your LLM to say no, but it's about if it can hallucinate, how do we leverage that? How do we take that uncertainty as a helpful tool? Um, and I'm going to show a few things that illustrate where LLM can be valuable. It can come up with term definitions, comments, descriptions, summaries, and all of those seem very reasonable. And it helps us in the modeling process. It helps us in the documentation process. It helps us in the writing, in the summarizations, or the other way around to extract and distill key terms from a larger body of knowledge. And all of that speeds our work up, but we still need to stay in the loop because exactly the reason is that hallucinations can make a mistake and it will tell you that with confidence. And this is due to LLMs working stochastically. Hallucinations seem to be answered, but maybe unverified, maybe wrong, or maybe made up. And that mimics the human speculation. Even if we talk from person to person, we may get answers that are incorrect. So there's nothing new with that. And as an example, if we start working in an interview, the interviewer may ask, is every order must it be paid before delivered? And then the stakeholder might be able to say, no, that's not true because some orders are delivered on credit or partial deliveries happen before even a full payment is made. So in the no, that's not true, we find constraints. We find business rules that tell us the assumption is invalid. Payments is not always required before delivery. And the lesson that we learn from this is that constraints need to be discovered to learn what the boundary is of a domain and a boundary of term and boundary of context. And we all have this positive bias. This makes it interesting because we think we understand the domain that we need to work with, but we forget to ask for the negatives. As soon as we do an interview with domain experts and this person starts to share his knowledge, we listen, and as soon as we think that we understand, we're also trapped into this positive bias because we assume. And this is the same with LLMs. It can provide summaries and answers or suggestions, but if it confirms what we already think that it should do, then we might be trapped into this positive bias. So I was really trying to find the LLM capability uh, to hallucinate and leverage that to make me more critical in my interview. So let's take a little example. I talked about some of these checkups. It has fact statements. In the information modeling and in the interview, we break it apart in various components. We depict that graphically. And from there, we can find all these different terms. And the first thing that we can do is open our details screens and say, okay, we have this term called checkup. But let's ask our LLM to complete some of the information that we have there, and specifically the top part, which is all about the semantics. And it comes very confidently with a result that says, okay, I kind of know what the plural of that is. I might give you some aliases, such as a physical exam, the health check, and I can even suggest an abbreviation for that. On top of that, can you please provide some comments? And the LLM comes back nicely with checkups are important for preventive care and early detection of health issues. But there's more to learn from that, because we might also be in need of a more formal definition. And again, it's text and LLM can generate that fairly easy. And even when asked for some examples, it makes up some instances that might be relevant for our use case. More interestingly, for me, is to help drive the interview and help question our positive biases, let it generate some questions that would actually help me to think outside of the box. And all of these might be hallucinated because there's no way to say that these questions are relevant or not. But they help me think outside of the box. It helps me drive the interview with the domain experts. So let's look at some of those phenomena. For the checkup, an LLM may generate a definition. A checkup is a routine visit to the doctor where your overall health is assessed. Now, I could run with this, but this would be my positive bias because I'm assuming that the definition is correct, but I also need to ask very critical questions. And instead of me asking critical questions, I can ask the same LLM, please state some questions so that I can verify this definition. And this is with the area where it can hallucinate the hell out of it because I can confidently say that whatever question it is, there's never an invalid question. So does a checkup always include lab work or imaging? Is a checkup the same as a physical exam, or could it be narrower? Could it be just blood pressure measurement? Or from an insurer's perspective, is it billable code or is it just a general term, which points back at the actual definition? So what we learned from this is that we may need to break terms up into more precise processes. I need to identify roles. I need to find context. So all of this helps me drive to better understand the domain that we're working with. And I have a few more of those examples. For instance, the emergency. Now, again, an emergency is a serious medical situation requiring immediate attention. It sounds very plausible, and if we would leave it at this, we're already again in our positive bias trap. We need critical, quick questions, and so the LLM then says, okay, immediate by whose judgment? The patient, the triage nurse, the doctor? And does an emergency always imply life-threatening conditions, though legal insurance definitions differ from clinical ones? These are all relevant to better understand the domain that we're working with. And we can learn from these questions. So I'll just do one more, not entirely without controversy, thanks to COVID. But let's assume that this definition is proposed. A vaccination is a shot given to protect against disease. And again, I immediately can ask questions about that. Isn't a vaccination always delivered by injection? Or can it be oral or nasal? Does vaccination guarantee lifelong protection, or are boosters required? Is vaccination the act itself, the substance, or the resulting immunity? Now, those questions help us in critical thinking and not just assume that the LLM answers are correct. And it helps us in driving the interview for more knowledge. So if we model the checkup, and I use the fact-oriented approach that I briefly mentioned, I can enter the fact expressions. I have examples which will lead to a graphical model. And it could be just this, but I also want to visualize all the questions that if I present this to a domain expert and show him how the knowledge is connected, how the relationships are formed, that it also shows what are the critical questions to keep talking about the interview. Now, not everybody is able to understand these kind of diagrams, so we have various outputs. One of them is, for instance, the concept map. It just shows you the terms and lines for relationships. But in here, it also presents what is the content generated by LLMs, what is the comment, what is the definition suggested, and which questions can be asked about it. So even on a very high level, we can keep communicating with the people that actually work with the data. Now, as soon as we start building software, we need a different kind of diagram to show how entities are related, which kind of attributes they have. But also there, I would like to present those questions. So driving all the way from interview to artifacts and weaving in the LLM capabilities brings it that all the critical questions not only stop where they are met, but also are brought forward all the way to the actual implementation. And another, a logical diagram for database development. You can see here it also represents the terms as database views because I have person first name both in the employee table as in the patient table, and I can union those and represent those again. And the questions remain at the checkup level was what was the last checkup for this patient? And those questions remain because it's not able to store it in the current data model. So bringing those critical questions into the interview with the domain expert, but also bringing it all the way forward to people that actually build the software, so that if somebody misses a question, someone else will pick it up, which is a great benefit of using this extra cycle. Now, with fact models, we can generate all kinds of artifacts, not just XML, JSON, and SQL, but also we can generate a Python script to train natural language processing frameworks. And we weave in the interview that we do with natural language modeling with the LLM, with NLP to drive development and even further enhance the text analysis capabilities. We have a lot of tools and databases and other technologies that we support in that. And it helps drive the LLM by having more exact ontologies again. So the benefits for stakeholders and modelers, for stakeholders, it's easier to respond to correct, wrong, or uncertain statements. This is the feedback cycle that we need in the process, not just the human in the loop for the LLM, but also the human in the loop for producing technical artifacts. In the interview level, it stimulates the engagement with the experts and the stakeholders and their participation. It improves the communication and, in the end, our data quality. And for our modelers, it helps us train our critical thinking. It eradicates implicit assumptions because it is questioning it all the time. It's almost like you have a sidekick in your interview who's allowed to ask dumb questions. The way that we integrated it allows the modeler to remain elusively smart, where our LLM plays the intern that is allowed to ask silly questions. And it strengthens our use and understanding of terms used in our vocabulary. Now, from all of this, I would like to summarize our key message here. The fact-oriented modeling produces high-quality models, and they are models by humans and for humans, and they require verification. It is grounding the terms and the information models from an abstract level to a very concrete level by using examples. Examples, by the way, that can also be generated by an LLM, because it's also helpful to have made up examples that we can then invalidate. And again, the LLM hallucinating is actually helpful. So they are real accelerators for text-based modeling, which aligns perfectly with fact-based modeling. Be aware of your positive bias. If ever you work with data, that data is created for a specific context. And usually we use data outside of that context. And we may conclude or think to understand or go with the suggestions made by AI, but be very aware of your positive bias. And find the constraints. Only finding our confirmations is not good enough. We need to find the knots. They are crucial in understanding and verifying that we understand. And finally, the questions may be more important than the answers. And this is a kind of a 42 is the answer. And for those who do not get the reference, The Hitchhiker's Guide to the Galaxy is a very good one. 42 is the answer, but once the answer was given, nobody understood what the real question was. So hallucinated answers may mislead. Hallucinated questions enlighten us. For those who want to know a little bit more about this fact-oriented modeling and how we use that, there are two books available. One is a more fundamental and theory. It is written as a self-learning book, which is fact-oriented modeling with FCOEM. And there is a recent book by my hand called Just the Facts, Information Modeling with Business Communication, which addresses the audience from management to architects, modelers, and developers, and show how communication is the ongoing continuum in this entire process.